Okay, here we go, number 30. Let's see, we're still trying to find the next four terms in the sequence. We got 2/3, -1/3, -4/3. So let's call this a sub k equals, let's see, we got 2/3, then -1/3, and -4/3. So our common difference here is going to be, well, 1, right? 2/3 minus 3/3 is going to be -1/3. So we're subtracting 3/3. And we're subtracting 3/3 here as well. So let's just continue to do that. -4/3 minus 3/3 will be -7/3. -7/3 minus 3/3 would be -10/3. And then -10/3 minus 3/3 would be -13/3, etc. And off you go. All right, number 33 is on the next page, it looks like. Bear with me one second. Okay, determine whether each sequence is geometric. Okay, looks like we've done a couple of these, but let's keep going. 33. Let's see, 21, 14, 7. So we'll call it a sub. Let's call it a sub b. Sure, why not? Equals. So we've got 21, 14, 7. 21, 14, 7. Okay, so if we're looking for geometric series, we're looking for a common ratio. So what do we have to divide 21 by to get 14? Well, let's go here and see if we go. I mean, it's like, what's that, 2/3? But let's get a whole number here. So 14 times what is 7? This we're multiplying by 1/2. And 14 is not 1/2 of 21. So right there, we know that this isn't geometric because this ratio is not the same as this ratio. So the answer is no, because we don't have a common ratio here. And if we really want to, so 7 times 21 is, well, we could take 7 times 21 and take the square root. We're not going to land at 14. That's another way to show that it's not a geometric series. All right, so next we got 36. And let's call this, let's call it b sub r equals 162, 108, 72. So 162, 108, 72. Okay, so let's figure out the ratio of 162 and 108. Let's just use a calculator for that and see what we get. 162, actually let's go 108 divided by 162 is 2/3. So we have to multiply 162 by 2/3 to get 108. Now let's take 72 divided by 108. 72 divided by 108 is also 2/3. So 108 times 2/3 equals 72. So we multiply this by 2/3 to get here, and we multiply this by 2/3 to get here. So this is, in fact, geometric. All right, 39. We'll call this a sub n, because that's what you'll see mostly. 39. Find the next three terms in the sequence. And graph. I will not graph, but you're welcome to graph if you'd like. So we got 0.125, -0.5, and 2. Interesting. -0.5 and 2. Okay. It looks like if we multiply each term by -4, let's figure out, this obviously isn't arithmetic because we'd go starting positive, going to the negative, we'd go further into the negative if it was arithmetic. So let's think in terms of geometric. What's the ratio of these two terms? Okay, so 0.125 is an eighth, and 0.5 is a half. So if we multiply this by 4, 0.125 by 4, we're going to get 0.5, but this is negative. So look what happens if we multiply this by -4. So times -4, 0.125 times -4 is -0.5, and -0.5 times 4, well, 0.5, if we move the negative, 0.5 times 4 is 2. 1/2 times 4 is 2. If we take the negative, we just have to multiply negative times a negative is a positive. So we multiply this times -4, we're going to get 2. So our common ratio here is -4. So let's just find the next couple terms. 2 times -4 will be -8. Negative 8 times negative 4. Well, 8 times 4 is 32. So negative 8 times negative 4 would also have to be 32. And then 32 times 4 is 128. But we're multiplying by negative 4, so it's going to be negative 128, etc. Right? That's the next one's going to be positive 512, and negative 2000 something, 2048, etc. Right? So the trick is to find. We know that it's not arithmetic, so let's think in terms of geometric, and we can find the next several terms that way. Okay, number 42. Let's see, 42. Let's see. Next two terms. So we have 81, 108, 144. So 81, 108, 144. I don't know, we'll call that A sub Q. It doesn't matter. Okay, so 81. Okay, so it looks like, let's find the difference between 80. Well, I know that we're, if I take 81, the number I'd have to add to it to get 108 is going to be an odd number. So we get even here. And then if I add an odd number to an even number, we'd get another odd number. So I know that we're not dealing with an arithmetic series. So let's check and see what our ratios are here as far as a geometric series. Let's take 108 divided by 81. That's 1 1/3. So 4/3. So we're multiplying this by 4/3. Multiplying 81 times 4/3 to get 108. Let's see if that holds. What's 144 divided by 108? Is 4/3. It's 1 1/3. So we're multiplying by 4/3 in each step. 81 times 4/3 is 108. 108 times 4/3 is 144. So let's just keep doing that. 144 times 4/3 is 192. And that times 4/3 is 256. And then 256 times 4/3 is whatever. Let's see, times 4 divided by 3 is, oops. 256 times 4 divided by 3. That gets interesting. It ends up 341 1/3. Interesting. So it keeps going. So 341 1/3, and then we'll keep going from there. All right. So 45. And graph it if you want. That's up to you. I'm just plotting points. So 45. We've got, where are we at? Determine whether each sequence is arithmetic, geometric, or neither. Explain your reasoning. So 45, we got 3, 12, 27, 48. A sub n equals 3, 12, what was it? 3, 12, 27, 48. Okay, if it's arithmetic, there'll be a common difference here. So 3 plus 9, so the difference here is 9. 12 plus 9 is not 27, so it's not arithmetic. Let's see, 3 times, what's the ratio of 12 and 3? It'd be 4, right? 3 times, no, it's not. Yeah, it is. My goodness, my brain is fried. Let's see, 12 divided by 3 is 4, right? Of course. And 27 divided by 12 is not 4, so we know that we don't have a common ratio either, so it's neither. If it was arithmetic, there'd be a common difference here. If it was geometric, there'd be a common multiple here. There's not, so it's neither. So let's go with 48. Let's see. Negative 2/5. Call it A sub n equals negative 2/5. Negative 2 25ths. Negative 2 125ths. And negative 2 625ths. Okay, so obviously there's not a common difference here because there's a tiny bit of difference here, and that's obviously not going to work. But let's look at what happens here. 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625. So really, we're multiplying each term by 1 over 5. Negative 2 times 1 is negative 2. 5 times 5 is 25. Negative 2 times negative 2 times 1. So our common ratio here is 1/5. Negative 2 times 1 is 2. 5 times 5 is 25. Negative 2 times 1 is 2. 25 times 5 is 125. Negative 2 times 1 is 2. 125 times 5 is 625. So our common ratio is 1/5. throughout all these terms here. So this is geometric because we have a common ratio. Number 51, we're getting there. Probably didn't need to erase that, but I did. Let's see, 51. Reading is, oh man, this is really hard to read. Sarita took an 800-page book on vacation if she was already on... Oh man, I'm sorry guys, I can't even see that. The book didn't copy very well. I'm going to go straight to 54. Let's do 54. Let's see, so explain why the sequence 8, 10, 13, 17, 22 is not arithmetic. So a sub n equals 8, 10, where are we at? 8, 10, 13, 17, 22. 13, 17, 22. Well, arithmetic would mean that there's a common difference between each pair of terms. Well, we have to add 2 here to get from 8 to 10. We have to add something other than 2 to get this term. It has to be 3, but this difference is 2, this difference is 3. Right off the bat, that kills any chance of it being arithmetic. So that's why, because we don't have a common difference between terms throughout. So 57. Let's see, error analysis. Brody and Jen are determining whether the sequence 8, 8, 8, 8 is arithmetic, geometric, neither, or both. Okay, well, let's just check. So we got a sub n equals just 8, 8, 8, 8, 8. Yay. Okay. So to test to see if it's arithmetic, we would take the difference of each term. Well, the difference here is 0, and the difference here is 0, and the difference here is 0, etc. Right? So we have a common difference between each term. So it is arithmetic. And to test to see if it's geometric, we'll take the ratio of each term. What do we have to multiply 8 by to get 8? Well, 8 times 1 is 8. 8 times 1 is 8. 8 times 1 is 8, etc. So we have a common ratio as well. So it is also geometric. It is, in fact, both. Not a very interesting sequence, but it is, in fact, arithmetic and geometric. Number 60. Hopefully, still have time here. Good. Number 60. Very last one. I guess it's on the next page here. Okay. Where's that at? 57, 58, 96. Okay. Describe what happens to the terms of a geometric sequence when its common ratio is doubled. What happens when it is halved? Explain your reasoning. Well, let's take a look at this. Let's just write at random. Let's see, a sub n equals, and the most common geometric series is just starting with 1. So 1, 2, 4, 8, 16, 32. That's a pretty simple thing. So we're multiplying by 2 each time, right? So if the common ratio was halved, so now we're multiplying by 2. So here we're just multiplying by 1. Actually, let's do a more interesting sequence because that's going to end up being a little bit weird. It's a special case. Let's multiply by 4 each time. So it'd be 1, 4, 8. I'm sorry, 4 times 4 is 16, 64, etc. Right? So our common ratio is 4. Let's cut the ratio in half. So now we're going to end up with 1. Now instead of multiplying by 4, multiply by 2. So we have 1, 2, 4, 8. Okay? Look what happens here. 2 squared is 4. 4 squared is 16. 8 squared is 64. Right? So we actually end up getting the, if we cut our ratio in half, we actually get an